So in this video we are going to have a look at the Moivre's theorem. Good news about this theorem is it's in our log tables, so we don't need to memorize it. Just so you are familiar with it, it tells us when we're given a complex number that's risen to a power. So that's my complex number inside the square brackets. It's to the power of n. N can be any number, positive. And then for our answer, we'll raise the modulus to that power, and then you multiply into your trig identity, so it becomes cos n theta plus I sine n theta. So for this question, we have two steps. So we need to write the number in polar form. Step 1, which obviously has its own set of steps, and then step 2, we apply de Moivre's. So we see here we've been given 2 plus 2i. We're going to deal with that by itself for a second. So 2 plus 2i, always draw a quick sketch. Here's my argument, theta modulus, and we have 2 and 2. So for our modulus, it'll be the square root of 2 squared plus 2 squared. Into your calculator, I'm going to get 2 root 2, and then we have theta is equal to tan inverse of 2 over 2. Make sure your calculator is in radians, and we get pi over 4. So we can rewrite our complex number in polar form. Okay, that's step 1 done. And now step 2. We need to apply de Moivre's theorem. So they tell us it's r to the power of n all on cos of n theta plus I sine n theta. So we have z. And they want us to find z to the power of 8. So that'll be 2 root 2 to the power of 8 on cos of 8 times. We multiply in for the trig identities. And then your best here to work this out kind of bit by bit. So into your calculator, 2 root 2 to the power of 8 will give us 4096 on cos of, so 8 pi, tidy this up first, so that's 8 pi over 4 would be 2 pi plus I sine 2 pi. It's always safer to oversimplify your steps here. Cos of 2 pi will give us back 1 plus sine of 2 pi is 0, so 0i. And now we multiply in. So just at the end you can give it back to them. So they had 2 plus 2i to the power of 8 is equal to 4096 plus 0i. And that's your answer using de Moivre's. So step 1, get your number in polar form, and then step 2, you can apply the actual formula. And that's us done.